Hey, it's Scott again. I'm following up on a video I just did on association rules and recommendation systems, and that was a collaborative-based method. And now we're going to talk about a content-based method. So just to review real quick, what we did in that first video essentially was we looked at association rules, right? So that is a type of collaborative filtering where you look at people that bought this might also buy that. That's a market basket analysis. So you look at the transaction history across different products, and you look at essentially the affinity for a purchase of item B based upon the purchase of item A is kind of the way you might look at that. Also, website recommendations, people that visited this website may also visit that website. And so the use cases that we looked at most as ones that everybody knows is the Amazon use case for recommending products, Spotify recommending songs, Bing or other search engines recommending different websites. So we're going to change gears here a little bit. So we're going to talk about content-based strategies here. So this is essentially you're trying to find out what is it about a specific product that's so attractive for a customer, right? What's the secret sauce that this particular customer is interested in, and you can do that a variety of different ways based upon their profiles and that sort of thing. But essentially, it's the secret sauce for that particular product or website or whatever service it might be. All right, we're going to go through this pretty quickly. So we're going to look at some different ways to a data scientist might measure the strength here. And I'm not going to go deep into the weeds here. I'm just kind of laying out some of the things that are talked about so that you can certainly do your own search, and there's a lot of good information available on these different techniques, but just trying to put some structure to what is content-based filtering methods. And so the other interesting thing is that you don't need to know anything from other profiles to influence recommendation. So essentially you're looking at a specific user's profile and trying to determine what categories, what genres, what things that they might be interested. So that's very unlike when we had the product history for all the different products that we were using before across. All right, so this is term frequency, or IDF, inverse document frequency. And so one of the things about this is you create this basically this matrix, and we'll look at one in just a second. But and then you look at you can do some matrix algebra to look at the frequency of certain things that occur. All right, so certain documents, right? So this is really used a lot in text analytics and a lot in just machine learning for corpus. A corpus is a collection of documents, and then you can compare that. So this is the primary use case for this TF and IDF is going to be in text analysis. And so term frequency is how often the term itself is in the document. Again, we'll see an example in just a second. And then IDF is how often the term appears in all the documents in the collection. And so typically when you look all the way across, it has a lower weight. But again, you can go into this deeper on your own. But for example, real quick here is if we look at across, again, these documents on the lower left, these are this is essentially a corpus that exists, and then what we do is we construct this matrix, right? So this across the top here we have document 1, document 2, 3, and 4. So those are the number of documents that you have, and then you have different terms that are pop up a lot. And then, for example, complexity is 2 times in document 1. The example given above is that romantic appears 3 times in a movie plot of 100 words. If there's 100 words in there, then it's 3%, 0.03, right there. And so the IDF is the log of the number of documents over the document frequency. So if there are 100,000 movie plots and romantic is in 1,000 of them, then we take the log of 100,000 divided by 1,000 and we get 2. And so that's the IDF. And then so the weight of the term is the 0.03 times 2, and which is 0.06. Okay. Euclidean distance, it's used all over the place in statistics. For example, the standard deviation, you know, is Mahalanobis distance. Euclidean distance is basically the a different distance. Well, it's algebra, right? So it's basically on a Cartesian point system that's given here. If you look at the action moving rating and the comedy movie rating here, the Euclidean distance is the distance between any of those 2 points within this Cartesian plane. All right, and then cosine similarity, it's a little bit more complicated, but again, it's used a lot in text analytics as well. With the movie analogy, it's stored in an item vector. This vector contains all the details, like the different dimensions, right? Like genre, cast, director. And so the algorithm finds the cosine of the angle between the profile vector, right? So these are profile vector, genre, cast, director, etc. And then you can apply this formula here, right? So the similarity of A and B is the cosine of theta, which is equal to the vector A times B over the absolute distance, or I'm sorry, the absolute the determinant basically of those. All right, so cosine, it ranges between -1, and movies closest to 1 are the most similar, right? And then, well, so there's a top-end approach where you peel off say the top 50 songs, and there's a rating scale as well. You can look that up. And then decision tree. So we've talked about decision trees in the past, but this is a little bit different in that we're not necessarily mining data to come up with the rules. We're actually creating kind of like a hierarchy, right? So you create a hierarchical structure. The example given below is all movies, and then you have the different genres, and then you create the ratings by genre, etc. And you can create these decision trees and see how well those recommendations are used, like the Netflix prize type thing as well. And then naive Bayes, you may be familiar with this, but essentially, you know, Bayes' rule, you can apply that, which is the inverse probability rule, right? So probability of A given B is equal to the probability of B given A times probability of A divided by the probability of B. And of course, this is just for simple units A and B, but you can do this across, actually, these are single variables, but you can actually do a multivariate unit of this. And by the way, so beta distribution is very popular for Bayes rules. Dirichlet is a multivariate complement of that. And then Pearson. Pearson is used all the time. This is the continuous numerical scale for most types of correlation, and there's the formula there. We won't go through, but if you see simple R squared or R, actually R is the Pearson's correlation. It's the association between two numerical variables, And the other thing that is useful sometimes is called Spearman's correlation, just FYI. And if you have a asymmetric distribution, you might want to consider something like that. That's a rank that uses rank order for its sake. So that was pretty quick. I could do another one on cluster methods for recommender systems that's sometimes used. There are a lot of different things that are used, but I'll check the comments and see if anybody wants to see that. Otherwise, I will apply my efforts elsewhere. Thank you very much. I appreciate it.